Hello and welcome to this lesson on rigid transformations. We are starting with the picture in front of us right now, and we are looking to see what we can observe about what is happening. So if we kind of look closely here, we can see a couple different things. We have three shapes that are all parallelograms. And we also notice that there are some repeated letters, like in parallelogram S and M, there's some repeated letters. We have different letters in parallelogram D, and we have kind of an origin point for O. So comparing first shapes S and D, we can see that they're obviously not the same shape, but they do have all of their angles. They seem to be equal if you kind of match them up together, from D to H and C to G, A to E. All those angles seem like they're the same size, but definitely not the same shape. But you can kind of see how you could draw some lines going back to an origin point at point O. Now, contrary to that, we can see that parallelogram M, that kind of seems to be the same shape and the same size of this parallelogram ABCD over there. And we could probably surmise that it just has moved from here to down here. So you want to pay close attention that you have basically the original image of this parallelogram here, and then it just moved over here. So when you have moved a picture, there's names for that. And so you could label this smaller one as the pre-image. And then you could say this parallelogram here is the image after a transformation has happened. And we can say that we could define a rigid transformation by saying that this has moved down here, but the size of all the sides of the shape and the angles at the corners are all exactly the same and haven't changed at all. So these are known as rigid transformations, when nothing changes about the shape other than where it is located. And we can write that down here as an observation. Lastly, we can see that some of these shapes, like C right there, have a little apostrophe above them. So you could compare it with the parallelogram in the top left corner, and you could say that you are going from the pre-image. So the pre-image, you could say, is at C, and then the image, which is the one that takes place after, that C with a little period, that is known as C prime. So you could write it as, quote unquote, C prime. This is not the last time you'll see that sort of apostrophe as a symbol in math, but the next time after this will be quite a while in calculus. So for now, we want to think of any point that comes from an original or a pre-image is going to end as the image and be C prime. And whenever your shape doesn't move or doesn't change in shape or size, it just moves somewhere different, that is known as a rigid transformation. So moving to our next part of this, we have the same shapes from a second ago, and we are looking at a line M that's been drawn through this. So you'll notice, and you might know what this is called, when shape moves as this is called a reflection. It is a perfect mirror image from parallelogram ABCD down here to parallelogram ABCD prime. And you can see that these construction lines are connecting the corresponding points to each other. So you can see that A is 2 spaces from this reflection line M. And we could even write up here, line of reflection. That's what this line M is. And you can see how that these dotted lines are perpendicular, or they're hitting that line of reflection at a 90-degree angle. And that's going to be very important, and we'll come back to that in future lessons. But we want to talk about what a reflection actually is in this next part. We want to define what reflection is more formally now that we're looking at a reflection. So if we are trying to define reflection, we can basically see that every point of the original figure ends up on the other side of our line of reflection, which is here, this when we noted before, and they are staying the same distance from that line. So let's write that down real quick. Every point of the figure ends up on the other side of the line of reflection and remains the same distance from the line. Now that is what we call a reflection. Another straightforward and kind of easy transformation to grasp is a translation. So a translation would be just moving a shape a certain distance away. So if I were to take this original shape and draw another pre-image, I could just move it, point A here, 1, 2, 3 spaces away. And I could place a point there, and then I would do the same thing to the other points. 1, 2, 3 spaces away for point D, 3 spaces away for point C, and 3 spaces away for point B. And I could just draw this shape here. And that would be a translation. A translation is just when a figure has all of its points move the same distance in a specific direction from where they started out. And it is the other main type of transformation we'll be focusing on in this lesson. Now, if we keep moving to our next part, we're going to be drawing some transformations using these two different kinds we've just defined here in this activity here. So we're starting out with a figure S here, and we're going to go through different transformations of it as we move through this. And we're going to draw each of these transformations in a different color. So we want to first translate figure S along the line segment V in the direction shown by the arrow. So we're going to do this in red. So we're going to move our point right here to right here. So we can kind of write down, that's kind of an easy part. And then so it's basically moving 1, 2 spaces. So I can move 1, 2 spaces like so. And then I'm going to move this one 1, 2 spaces. This point go 1, 2 spaces. This point go 1 and then 2 spaces. And then our last point 1, 2 spaces. So I can draw my red shape right here. So I've translated my figure S along that ray of V. So now we are reflecting figure S across line Y. So when we are reflecting, we want to keep the figure the same size and then be able to move it across and reflect a mirror image on the other side of line Y. You can see line Y up here down the middle. And then we want to keep it the same distance away from Y. So the best way I've found to do it, especially when you're doing it by hand, is to kind of do it by counting. So if I want to use this shape, 1, 2, 3 spaces, 1, 2, 3 spaces. And we're going to do this in green. And so then we can kind of just do it with all of these. We can do 1, 2, 3 spaces, 1, 2, 3 spaces. So we've done these first 2 points. So now we can count this outer point here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So now we have 3 of our points taken care of. So we have 1, 2, 3 points done. So let's move on to our interior point here, which would be 1, 2, 3, 4 spaces away from Y. So I got to count 1, 2, 3, 4 spaces. So we have 1, 2, 3, 4 points so far. And then we have our next point here, which we're going to count over as well. 1, 2, 3, 4 spaces. 1, 2, 3, 1, 2, 3, 4 spaces. And then lastly, our point down here at the bottom, 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4, 5 spaces. So we just need to connect our dots here to make the shape and our mirror image of figure S. So, and remember from what we just talked about, that we are starting out with a pre-image S, and we made one image by translating, and then we made another image by reflecting over line Y. You can see our dark green picture of that reflection right there. Next, we're going to do a little bit different of a reflection. So first we reflected over line Y, this up and down line right here. And then we're going to reflect over this diagonal line M. But the process remains the same, and we're going to do this figure S image in blue. So we want to reflect across line M. So if we are kind of looking at this, we want to be 90 degrees with line M. So that's kind of 1, 2 spaces. So I'm going to count 1, 2 spaces down. So I already have this point done. So I'm going to pick the next point over, this point right here. So it'd be 1, 2, 3, 1, 2 spaces, and then 1, 2 spaces right there. So you can kind of see how that flipped over, and you kind of draw the dotted lines to show that we've constructed that right there. So now if we keep moving up around the image, so we can even connect these 2 dots we've already drawn. We're doing 1, 2, 3, 1, 2, 3 spaces, and then we can connect those dots. And so now we have 1, 2, 3 spaces, 1, 2, 3 spaces, and we can just keep moving along here. We just did this point, so now we're going to do this point. 1, 2, 3, 4 spaces. 1, 2, 3, 4 spaces. So we started from this point right up here, and we counted 1, 2, 3, 4. 1, 2, 3, 4. And we kind of keep moving along here. So to the back point here, we're doing 1, 2, 3, 4. 1, 2, 3, 4. And we've essentially finished our shape right there. So we can just connect all of these points together, and we've created a shape here in blue that is a reflection. And you notice that this is still the same size as our shape from before, and we have created another equal shape of the exact same size. So now we have one more transformation here in part 2 of our lesson to take care of, and we're going to do this in another color. We're going to do this in orange. But we're going to need a kind of intermediate color. So we're going to say our intermediate color is pink, because we're going to translate First, translate figure S along the line segment W in the direction shown by the arrow, and then we're going to reflect it across the y-axis. So let's do that in order. So first, we're going to look for where W is. W is going kind of in this kind of southeastern direction, and we're going 1, 2, 3, 4, 5 spaces. So let's move all of these points 1, 2, 3, 4, 5 spaces in that direction. So 1, 2, 3, 4, 5 spaces. And we can do 1, 2, 3, 4, 5 spaces. 1, 2, 3, 4, 5 spaces. And then 1, 2, 3, 1, 2, 3, 4, 5 spaces. And then our last point, 1, 2, 3, 4, 5 spaces. And so we've drawn our translation first in pink. So that is part one of what is known as a sequence of transformations, which all that means is removing more than one space at a time, or more than one transformation at once. So now with our last part, we're going to do this in orange. We're going to reflect our shape in pink over the y-axis of this graph here. And we're going to just kind of make it easier on ourselves. You can see that some of these points are right on the y-axis. So I'm going to put those in orange. And then I can just reflect the point from here, 1, and then one more right across the y-axis. This shape is 1, and then 1 across the y-axis. And then this shape is 1, 2, 1, 2 across the y-axis. And I can draw that shape for us right here. And we've got two sort of transformations there in a row where we did a translation and then a reflection. And so we have that done right there. In number 5, it is asking us how are these shapes the same and how are they different. So if you look at all the lengths of these shapes we've made from our pre-image to all the images we've made, all of them have the same lengths of sides, and you're looking at all these angles. All of them kind of match up with each other if you're looking at corresponding angles here. And it doesn't change no matter what we did to it. All of these reflections and translations are rigid transformations. So we know that those are going to make sure our shapes are the same size. The only difference is that when you make reflections, how your shape is oriented, which way the points are facing, and that sort of thing, are all going to be different. So now we can move into our next and third part of this. So in this task, we're going to try to do more than one transformation at a time and see if it's going to matter if we're going to move them more than one transformation at a time. And so I've drawn in some lines that are going to be helpful in our reflections as we go through this. So I've drawn in line L and I've drawn in line M. So if I wanted to make figure A become figure B, we can notice that you can go from A to B, but they're upside down from each other. So the first thing I would have to do is move A over to the left 2 spaces to kind of line it up and down with our new shape B at the bottom. So I've just moved all of those points. So I have a new figure A, which remember, we can call this A prime. And then if I were to reflect that over this line L, well, I could take this point is 1, 2, 3, 4, 5 spaces, 1, 2, 3, 4, 5 spaces across L. And that kind of shows me that all of these points are going to stay the same amount of spaces away from their counterparts in this task. And so that kind of takes care of from A to B. We translated left 2, and then we reflected across line L. And that took us from A to B. So question 2, if you reverse the order of your sequence, will the reverse sequence still take you on to B? So we want to see if this actually is going to work. So if I took figure A and I reflected it first, that would take me kind of to this general area in green here that I'm drawing. And so we can tell then if I move further left 2, that would take me into that same figure B. So we can see that sometimes here when you if I was translate left 2 and then reflect across a line, that would surely get me to the same place. So the order didn't matter in this particular case. So let's see if we can get our figure to line C. So we have this line M, and we want to reflect A over line M, because we know that this C is oriented a little bit differently, so we can't just use translations. So let's reflect in red across A. So let's do that first. And we have basically just to count these, so 1, 2, 1, 2 and a half, half, 1, 2, and connect those to each other. And then we have this top point. We have 1, 2, 3, 4, 1, 2, 3, 4. And we can keep going from this point, 1, 2, 3, 1, 2, 3. And we have this front point, 1, 2 and a half, half, 1 and a half, 2 and a half. And lastly, we need to kind of connect some of our points together. And we need this middle point right here. So that's from this one, 1, 2, 3, 1, 2, 3. So that is A prime after we reflected over line M. And so we need to then look at how can we get from A prime to C. Well, that is easy to see because we can just move this point over 1, 2, 3 spaces right and down 1. And then all of these work the same way. 1, 2, 3 right, down 1, and that would get us to figure C. So we first in this number 3, we reflected across line M, and then first. And second, we translated right 3 and down 1. So we got to figure out if I were to do the opposite of that, would this still work? So we can use some different colors here we haven't used yet. We can use our blue color. So we need to do right 3 and down 1 first. One, 2, 3, down 1. 1, 2, 3, down 1. 1, 2, 3, down 1. And so we can kind of just draw out our shape from there. So we have our translated shape there. And now we have to reflect that across M. And so we want to see if that goes where our final point was here. So we can pick black. But as you can see, we are not going to end up having this work out perfectly for us. And 1, 2, 1, 2, we end up with a shape up here that is certainly not where C is. And so we can tell that order does in fact matter. So this was a no. That sequence of reflecting and translating didn't work the same way as what we tried earlier. So order does matter sometimes, but other times it doesn't matter. So it can be a tough thing to always know for sure what you're supposed to do with the order mattering or not. It can be changing depending on what you're doing. So that finishes off what we are working towards here. But before we end with kind of synthesizing what we've learned today, is that if we wanted to think about how we could take A to a new figure, D, without having to change anything. So if I wanted to move A to a figure and have it not matter what it would be. And a quick example of that, if I knew I was going to take A and I wanted to just do translations, I can move figure A 3 spaces left and then 5 spaces right. If I did 5 spaces right and 3 spaces left, it would still get me back to the same place. So whenever you're doing just translations, that is a foolproof way of knowing that it's not going to matter what order you do your transformations in. So the first thing we need to do to kind of wrap all this up is definitely write down some definitions. We've defined what a translation is earlier. So we know that translation is moving a shape by a certain number of spaces in a specific direction and doing the same thing to all of those points. And a reflection is where you take a shape and have a mirror image across a specific line where the new image is the same number of spaces away from the line of reflection as the old pre-image was. So there's some other things we want to talk about. Is we want to emphasize for rigid transformation, it could be a translation, a reflection, or a rotation, or any sequence of the three. It's always going to keep everything the same length, same measurement on all parts of the shape. And you can see on this figure has some geometry markings that we're going to see a lot of in this chapter and in next chapter, where if you see a line segment on a shape with 3 lines and 3 lines, that means those are the same length. Same with 1 to 1 and 2 to 2. And angle markings have the same idea. You have 1 angle marking, then 2 angle markings, and then a single angle mark with a line there as well. And the idea down here in the second part is the idea of something being congruent. Congruent, an easy definition for being congruent is same size and same shape. And you can see that from triangle CDE or EDC to E prime, D prime, C prime, this is just the translation, moving it in this sort of direction. And so the symbol for congruent is that right there. And I'll write it over by our word congruent. And it basically means same shape and same length. That's why it's a little squiggly line and an equal sign. And then finally, a reminder that our first figure is always the pre-image. Following a transformation, you are then making an image. And so lastly, we just want to look at some summary notes for this lesson and highlight some quick things. In that you got to make sure that you are thinking about congruency, whether something is the same or not, and no matter what kind of translation, rotation, reflection, you're always creating congruent shapes, and it doesn't matter what the sequence is, it's still going to be congruent. But the order of these transformations is definitely going to matter depending on what kind of transformations you are doing. If you're only doing reflections or only translations or only rotations, order is not usually going to matter, but if you are mixing and matching, frequently the order does matter. And depending on what we're looking at, you can kind of see in this diagram in our lesson summary here that you can see how your triangle would start out, and you might do a translation and then a translation, or you can kind of move it in different places and creating different congruent triangles. So that finishes off this lesson introducing rigid transformations. In the videos and lessons to come, we will go in much more depth on these individual transformations and how they all work together as we progress. Thank you for watching.